Hello, uh, I'm going to give a talk titled Enhance Your World with ARKit, and to be even more clear about the level of the talk, I subtitled it An Introduction. Hello, I am Marius Constantinescu. You can find me on Twitter if you want to contact me. I work at a Danish company called Greener Pastures, but I work from Romania. We have an office there. Since September, I'm taking care of iOS goodies. It's a newsletter going out every Thursday, so subscribe if you want to find the latest news in iOS development. The goal of this talk is to give everyone a short introduction to ARKit. I'm going to give some examples. We're going to discuss some use cases, and I hope to inspire you to try it out and come up with great use cases, make nice apps. Just as a disclaimer, my experience with ARKit comes only from demo projects. I haven't shipped any app with ARKit. Probably, I don't know, did any of you work with ARKit before? Just so I know. Okay, one person, two, three-ish persons. Okay, I think that's fine. This WWDC, the ARKit section, is the one that got me most excited. And I was looking forward to giving it a try, seeing what it can do. And I watched the WWDC session on ARKit a couple of times, but I kind of felt like that wasn't enough. And of course it wasn't, because we all know that this is the actual way to learn a new programming concept. You have to change stuff and see what happens. So I just got all of the sample code I could find on Apple's website, jumped into it, and change stuff, see what happened. We're going to go through some code examples now. Most of them are inspired from the sample code on Apple's website with a few changes. But first, before we dive into the code, let's take a step back and actually, what is augmented reality? Basically, augmented reality is it's a live view of the physical world, the real world around us, and we augment it by adding virtual components. It could be video, graphics, sound, GPS location, haptics. In other words, it's adding virtual stuff to the real world. Here's an example. It's taken from an Apple documentation. On the right side, we have the real world, the couch, the TV, and then if we look through the phone, we get this funny little dude, alien, whatever he is, waving at us. The thing is that augmented reality is not something new. It's been around since the early 1990s, but it's been only recently that we got a lot of hype around it. And most of it came with Pokemon Go recently. I'm sure you all know it. I played it a bit when it launched. Those are actual screenshots I took back then. And you can see it's quite nice to be able to see a Meow in my debugger or an Eevee in the soup bowl. And this was kind of the state of AR on iOS before this WWDC. But this WWDC, something changed. We got ARKit, which is basically Apple's framework for augmented reality. It was introduced this June. It works on devices with an A9 chip, that is iPhone 6s and newer, including iPhone SE, and on iPad Pros and 2017 iPads. So that's quite a lot of devices supporting it. And before this, you could still make AR apps, as you saw Pokemon Go, but you just couldn't get very good results. Why I think it's huge? I actually think ARKit is a very big deal because it makes creating AR apps very easy on iOS devices. It works even on a 2-year-old device, as I said before. And it's taking care of all the processing for you. You don't have to do manual computation, or not that much. And the fact that we have all those devices supporting ARKit, that makes it the biggest AR platform in the world. That's what they claimed, at least. I kind of trust them, to be honest. And it gives much better results than what we had before. This is a video taken, it's from the keynote. It's the same Pokemon Go, but you can see here that Pikachu is actually jumping on the ground. The ball bounces nicely. They're not floating around anymore like they did in the previous screenshots. So let's see what ARKit does. When we say ARKit, we basically say tracking. It tracks your device in real time. And built on top of tracking, we have scene understanding. By this, they mean plane detection, hit test, and light estimate. And it also has rendering support for sprite kit, scene kit, and metal. You can choose those from Xcode when you create a new ARKit application. It also has support for Unity and Unreal engines. So how does it do it? I'm sure there will be a lot of questions about this even later, like how does the phone know where something is? Basically, ARKit is a visual inertial odometry system. This sounds like science fiction. It actually means that it's tracking where I'm moving as I move. It tracks the position, the 6 degrees of freedom. That's the position on X, Y, and Z axes, and the 3 rotations, yaw, pitch, and roll. It tracks via visual, camera, and via inertial systems, the gyroscope and the accelerometer. And then those outputs are combined. They're through a filter. There's some math, some physics behind. I won't go into the details of that because I don't know all of them. And it takes the best guess from those two to give the position through the ARKit SDK. And under the hood, it uses AV Foundation for the visual part and Core Motion for the inertial part, for tracking, for the movement. How do we start? Xcode makes this very simple, very easy. There's a template. You just go through Xcode, File, New Project, choose Augmented Reality App, and that's it. And then you have to choose the content technology. That's the rendering part. And we're going to go with SceneKit for this example. It supports SceneKit, SpriteKit, and Metal. You run it, and this is what you get. That's my office, and there's the spaceship. This is the basic app that you get when you run the empty template in Xcode. And you can see that the spaceship stays still as we move around it. Now let's look at the code a bit. And again, this is all you need for that example, and we didn't write a line of code to make that stuff from the video before. This is all generated by Xcode. So basically, this part, we create a new scene with that ship SCN. That's an asset coming with the project. And then we set it as the scene's root scene. And then we initialize a new ARKit session, and we run it. And we get the spaceship we saw before. We can also set ourselves as the delegate of the scene view, and we get access through the delegate methods, which are those. I've highlighted the ones that I think I found more useful, but depending on the use cases and on the app you're building, you could find that others are more useful. Yeah, it fits. Those methods, those delegate methods, can be used to configure the way that the objects look like. A very brief explanation, and just so you're not confused by SCN, Node, and AR Anchor. And basically, SCN, the prefix stands for SceneKit. That's the stuff that we see on the screen. It's the rendering part, it's the visual part. The stuff starting with AR Anchors, AR whatever, that's the ARKit, that's the processing part. That's computation, that's positions where things should be. And basically, yeah, those are the delegate methods. We use those to tell the app what should be shown where. And let's take some snapshots on the same example. So the same one with the spaceship. It's the same example, the one with the spaceship. This is all the code we have to add. Basically, in the beginning, we're adding a tap gesture recognizer. This is basic stuff. And then we handle it. And this is what we do. When we tap on the screen, we create an image plane and set its material to the current view's snapshot. That part with the scene view.snapshot, that's built in. We just set it as a texture of the image plane. And then we add the snapshot to the scene. And then we move it 10 centimeters in front of the user, the translation part, just so it looks nicer. And this is what we get. We tap, not yet, we tap now, and that ran off a bit. I didn't say it's perfect. That one stayed where it should be. So basically, we just take pictures and they're right there. Let's see how it detects the planes, because we can do that too. We got plane detection, as we said. In the configuration, we tell it to detect horizontal planes. And horizontal planes are the only ones that can be detected right now. But that's an option set, so I'm very hopeful that at some point we're going to get more options there, not only the horizontal ones. So we specify in the configuration that we want to detect horizontal planes. Those are going to be detected automatically. And we get this method, the delegate one, renderer d.node, which is called when a plane is detected, with that anchor being AR plane anchor. So we check that it's an AR plane anchor, just to make sure it's a plane, and then create a scene kit plane to be able to display it. We created the same size as the plane anchor, the AR anchor we detected. You notice here probably that we're using X and Z for the sizes, and that's because SceneKit uses this kind of system coordinates, where X is to the right of the user, Z comes towards the user, and Y is above. It's going up. And we create the plane of this size, and then we rotate it so it's horizontal. The Euler angles, that's basically with it. So we create that plane, and then we just lay it horizontal and add it to the scene. No, not yet. We add a nice texture first, semi-transparent, so we can see what's behind it. And then we add it to the scene, to the node. When the information for a plane gets updated, this is the method that gets called. And what we do here basically is we update the plane's width and height and center so it matches the detected plane. This way we make sure that every time the ARKit updates the detected plane, we update the visual, the part that the user actually sees. And here's a demo of what this does. So it detected the plane, we're moving there, it detected another one, and now it merged them together. That's really cool about the ARKit, that it merges planes by itself. We don't have to do that. Okay, we did plane detection. Now let's see what we can, if we can add stuff on a plane. And we're gonna add a lamp. That's just because a lamp was a nice asset we found in another sample project. We're adding two properties to the previous example, a lamp scene and a lamp node. And we'll do it the quick and dirty way. And we set the current scene to the lamp scene, which is currently empty. Then we load the lamp from the assets, and we keep the reference to it. And we add the tap gesture recognizer, so we add the lamp when the user taps the screen. And this is the part where we handle the gesture. We get the location in the scene view. We make a hit test and search for existing planes. If it's not empty, we get the first one, and we apply to the lamp the transform of the hit test relative to the world coordinate system. In other words, we tell the system to show the lamp where we tapped, and then we make it visible if it wasn't. And here's what the code does. Plane detection, and then we tap, and there's the lamp. The yellow dots, those are used for debug, but you can mostly for debugging, but you can also see them in lots of shipped applications on the App Store. Those are, from what I understand, basically results of the hit test. It's some point that the system considers interesting or important, and it's the ones that are tracked when I move the phone. Now let's see if we can move the lamp around. And to do that, we're going to add a pen gesture recognizer, similar to the way we had the tap one. And we handle the gesture. And you can notice probably this code is very similar. It's almost exactly as the one for handling the tap, because it's basically making the same thing. We're just applying to the lamp the transform that we got for the hit test result. And this is what we have. So first plane detection, then we tap, yeah, we made it bigger. We tap to add the lamp, and then we can just move it around. And there can be some very nice use cases for those. We added virtual objects in the real world. You can do lots of stuff with that. And one example which you probably heard about is IKEA Place. IKEA made an app where you can add virtual furniture into your homes. And it's quite nice because you actually get to try it out, see how it looks in your house before you buy it. That's in my office, and we already have two bar chairs from IKEA, and I'm just gonna add a virtual one next to them. There it is. And we align them as close as we can. I found it a bit hard, the user interaction, to rotate it, but maybe I have thick fingers. So that's a virtual one and the real one. They're kind of similar. It's a small difference in size, but maybe that's just my phone being old. It's 6S. And that's an app you can find on the App Store. Initially it was available in the US, but I think it's spread more widely now. Another use case that I found really interesting is this. This is a game, Conduct AR. It started as a Unity game without the AR part, Conduct This. It's a puzzle with trains. The goal would be to tap on the trains to stop them or to start them, and you can use the switches to switch directions on the tracks. And the goal would be to move passengers from one place to another. The idea is not to have the trains collide, so that's why you have to stop them and start them at certain points. And in the first version of the app, in the normal one with no AR, you would just see the whole map at once. But then this summer they made an AR version where they would just lay the map in the real world on a table like here, and you can notice that you can't actually see the whole thing. There are some tracks there, and you have to go around the table so you can see it from all the angles. And I think this is a really nice use case for AR. And this is another use case I found. It's a GitHub. It's a project on GitHub. It's open source. It's called ARKit Core Location. It just gives directions as you move, and you can see them, just huge signs. And you can also see on the right side of the slide, it can point out points of interest on the map. So there are lots of things you can do with ARKit. Those are only some of them. But you can also do measurements. You probably figured that out since we saw the directions example before. All the code we've looked at, it added virtual objects to the real world with the purpose of seeing them there, interacting with them, enhancing the user's experience. But we can use ARKit just to measure stuff. We don't really need to add virtual objects. I mean, we are going to do that in order to be able to measure stuff, but it's a bit of a different use case. So we're going to start with the basic plane detection example. No more lamp adding and tap gesture recognizer, pen gesture recognizer yet. It's just the plane detection that we saw before. And we need to keep a reference to an array of SCN nodes. When the user taps the screen, we're going to add a sphere. He taps again. We're going to add another sphere at the point where he tapped the second time. Then we're going to compute the distance between the two spheres. And then we're going to show that distance on a label. This is more or less all the code you need for that. So I hope you can see it in the back. You can't see it on that screen, unfortunately, so I recommend looking at this one. We add the tap gesture recognizer, and this is how we handle the gesture. We compute the point where the sphere should be placed. We create a new sphere, just make it green, give it a small radius, so it's not too intrusive. Then we measure between two spheres. So when we tap, we check if we already have one. Or if we already have one, we're going to measure. If we have two, we're going to clear them and start a new measurement by adding the first one. Now that we checked that, we're adding the sphere to the scene where we tapped. If we have exactly two spheres, we're going to compute the distance between them. And I won't really go into details here about how we are going to do that. It's but it's very easy. It's basically, we have the positions of the sphere. It's just computing the distance. It's basic mathematics. It's square root of the differences of each coordinate times, yeah, to the power of 2. And here it is in action. This is my desk, and I'm planning to measure the keyboard. It's detecting a plane. We made it big enough. Now we tap, so we have the sphere there. And then we move slowly. We tap again, and we got the distance of 40 centimeters. I didn't really check, but I think that's pretty accurate for the keyboard length. Some things you should know, things that I found out the hard way. The plane detection only works for horizontal planes. So, for example, one use case I thought of, do you know, there's an app called Vivino for scanning wine bottles. It scans the label, it gives you a rating. It's a user-generated stuff. So the users rate wines, and then there's an average, and you can basically see how good a wine is according to all the other users. So I thought, let's think we're in a supermarket, take a picture of a shelf filled with wine bottles, and then scan that and show labels on top of each of them. But we need vertical plane detection for that. We can also do it with horizontal, but it's going to be more tricky. So yeah, we're going to have to wait with that. And another thing, take care of your users. There are lots of things happening behind the scenes that can go wrong, and the user has no idea what's happening there. So just show him information, labels, dialogues, whatever. Things like try moving around or turning on the light. And yeah, it's quite hard for the normal user to understand what's going on there. Basically, it's a black box, and you get results. And if you don't get them, the user will not know what happened. And remember to add ARKit to the UI required device capabilities in order to limit the installation only on devices that actually support them. Because otherwise, you're going to get one-star reviews from frustrated users. And some things I learned the hard way is that lighting is super important. I worked on the demos here in the evening when I came back from work, and the light in my living room isn't good enough for ARKit to detect planes. So I had to buy new light bulbs. And previous knowledge of SceneKit or SpriteKit or Metal or previous knowledge of rendering stuff helps a lot. I know that because I wasn't familiar with SceneKit. And since the conditions in which you run the app are very important and they are different almost every time, the light depends on the weather outside, the season, the hour, just don't expect the same result every time. It can happen that it's just not going to work, or it's gonna be different, it's going to look weird or whatever. And you can try to improve and prepare for that, but that's just something we have to live with. And yeah, make sure the user knows that. And that's kind of all from me. And I hope I made you curious enough to try ARKit. And let me know if you have any questions. I'll do my best to answer.
Thank you for the great lecture. So I have the question. So we can manage the objects only on the defined plane, or we can put them anywhere in the camera that we see, in any way of the coordinates?
I think you have to put them on a plane.
Only on defined plane.
Yeah.
That a camera are defined, and after it defines, then we can put the element.
You can probably put them in random places, but I wouldn't see why you would do that, because in order to bring the best in ARKit, it's easier if they're on a plane and you know on which plane they are. And for the measurement, for example, we need the spheres to be on a plane to be able to compute the distance between them.
And also the question about collisions, how to avoid them.
I don't think collisions. You mean collisions between virtual objects?
Yes.
I think
or objects with like a virtual object with a real object.
Yeah, virtual object with real object, that's a problem, because I don't know if you can. Let's see the IKEA demo where I added the chair. next to the others. I think I went past it. It's not doing that good. Is it? No, it's not this one. It's going through the wall, basically.
Oh.
Yeah, this one. I think we're gonna have to watch all of it. I don't know if I can.
Because we can't define the vertical planes.
Yeah, I think that's the problem. And collision between two virtual objects, that should be easy to determine, just
Yes,
like in
because of
game programming.
coordinates.
But between real and virtual objects, I don't think there's much we can do.
Thank you.
I think I'm going closer to it, and you can see it's gonna go over the edge, basically, on the wall. Yeah, it's not perfect, but it's something, and it's quite nice, I think. Any other questions? Apparently not. Well, I hope I made you curious, and I hope we're gonna see some nice ARKit apps. Thank you.